So you have that FIP quiz, and I typically make extra copies. If you didn't do so well on this one, and we go over it, and then like sometime in the middle of next week you say, hey, you know what, I've been practicing with this, I feel like I'm ready. Can I retake that quiz? Yeah. Now, I mean, I'm not going to, you know, unless you want me to, I'm not going to put another note in the margin that says, okay, took it this time, got a 6 out of 6. It's for you, but then I'll have the key up on a bulletin board, and you can just check your own stuff. And that way you can see where you're at, and you know, by the middle of next week, you'll have forgotten these problems. So you can retake the same thing. Okay, on the first one, we have 8.300 times 10 to the 7th plus 2.6 times 10 to the 8th. So since we're adding, the exponents have to match, and then we don't do anything with the exponents. I know a few people wanted to add those exponents or multiply them in some way. And when we're doing addition and subtraction, we just make sure that they match, and then we don't have to touch them. When you have large numbers, it's easier to go to the higher exponent. It makes your life a little bit simpler. So if we are going to convert this times 10 to the 8th, we got 8.300, etc. And if we imagine moving this 7 spaces over, so I'm going to do my stupid little, I look like a middle schooler, little bumps underneath, little bumps over top. Don't care. It saves me errors. So I finally said to another adult science person who teaches science, I said, you know, I feel like a 5th grader because I have to go bump, 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 bump with little lines. And they said, how else would you do it? So there may be a more elegant, more adult solution, but I draw little bumps. It's okay to draw little bumps. Humph. So I'm starting out here, and I'm going 1, 2, 3, 4, 5, 6, 7. When I come back the other way to get this up to the 8th power, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that means that this has to be 0.83, well, 0.8300 times 10 to the 8th. Now we can add that to 2.6 times 10 to the 8th. So now we're just adding 2.6, we're adding 0.8300 plus that, and making that whole thing times 10 to the 8th. So we end up with 3.43 times 10 to the 8th. You guys don't know why yet because we haven't talked about sig figs, but the final correct answer on that would actually be 3.4 times 10 to the 8th. All right, questions, comments, concerns? So remembering rules for addition and subtraction, make the exponents match, and then you don't have to do anything with them. Okay, so here is subtraction, but that's not the neatest trick in the little playbook. Negative exponents. And negative exponents, I can tell you historically, students have more problems with negative exponents than they do with positive exponents. I don't know why, but they do. This is making the number smaller, and when you're dealing with negative exponents, it's easier to go to the smaller exponent. So I'm going to convert everything down to the negative 8. So I leave my 6.9 times, well, I'm not even doing it with that yet. So I'm going to give myself an entire line to just mess around with my exponents. I'm going to give myself that space because I have it. So I know that I have 5.9, and this was to the negative 9th. There are a bunch of zeros there in my imagination. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I come back to get it to the negative 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 0.58. times 10 to the negative 8. 6.9 times 10 to the negative 8. Oh gosh, yeah, sorry. Miswrote. Gotta watch me every second. Keeping you on your toes. Okay. So at this point we can just do the math, and we end up with 6.31 times 10 to the negative. Okay. A word about the little middle school bumps in multiple colors. And I find I always, like, I can do calculus. I got A's in calculus. I love math. I love algebra. Basic arithmetic and moving decimal points trips me over my own feet every single time. Why should that be? I don't know. But it makes me feel like I got a little tiny pea brain. But I've made these mistakes, so it's okay to make them, and I can hopefully tell you how not to make them. Once we get into the swing of this for the year, I don't have to go all the way out to the 9th. I'll just start to see, like, oh, okay, I'm going this way, and then when I come back one more, that number will be one more or one less. Because, of course, it's different for positive and negative exponents, which is why I count bumps. Okay. And again, for reasons that you guys don't know yet, because we haven't talked about them yet, the final true answer for that would be 6.3 times 10 to the negative 8. By next year, you'll know all about zig zags, and you'll be arguing with one another about them, which is always my favorite part of physics. Number 3 was your first multiplication problem, and you had 4.6 times 10 to the 4th times 2.8 times 10 to the negative 8. Thank you. So, with multiplication and division, it's really easy. Remember, you just multiply these parts, and then for multiplication, you add your exponents. So 4.6, and I very often do this for myself, times 2.8, and then the whole mass times 10 to the 4 plus negative 8. And I actually do typically write that out for myself. When we start doing big factor labels, which we're going to start on Monday, where you have 5 or 6 different exponents that you're adding, and you've got positive and negative exponents, and you're adding and you're subtracting, I find it much easier, again, for my little pea brain, to not screw something up if I actually just write them down. So it seems cumbersome, but it does help. So the raw answer that you get is 12.88 times 10 to the, that would be negative 4th. But we have a problem there, which is it's not in correct scientific notation. There were a number of you who got this answer, but I still marked it wrong because I'm mean and evil. No, because it's not in correct scientific notation. So we're working on getting the correct scientific notation. Remember that for scientific notation, that first part can only be one digit, and it has to be between 1 and 9. So you cannot have 12 there. So we have to move that decimal, and I'm just going to stick some zeros here and do my little bumpy thing. 1, 2, 3, 4. 1, 2, 3. Whoops. Too far. 1, 2, 3. So 1.288 times 10 to the negative 3rd. And again, for reasons that we haven't talked about yet, the final answer would actually be 1.3 times 10 to the negative 3rd. Okay? If you made a mistake, do you see where? And I think a lot of people were going here like, I know this. I don't need to count bumps and humps, and that's stupid, and it's just one less, it's one more. So we have 3.9 times 10 to the negative 8 times itself, or squared. And again, we're just multiplying that first part, so we get 15.21. And it's times 10 to the negative 8 plus negative 8. Okay. Negative 16th. So we have 15.21 times 10 to the negative 16th. And to move that, again, I'm going to toss some zeros here. what I mean when I say, like, after a while I don't have to write bumps anymore is I'll start off whenever we start this every year actually doing every single bump, and then I start to go, let's see, okay, 2, 3, 4. Okay, wait, when I'm coming back, I'm going to go one less. So I no longer have to go the whole way because I start to see the pattern. It's just a matter of reinforcing it for myself. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, I get it. When I come back from 16, it's going to be to here, and it's going to be to the 15th. So we have 1.5 times 10 to the negative 15th as a final answer. And again, I'm not worried about your rounding right now. We haven't talked about that. We'll be talking about that at the end of next week. We have 6.2 times 10 to the negative 15th divided by 7.2 times 10 to the 8th. We're just dividing the front part. And then that whole thing will be times 10 to the negative 15 minus positive 8. Okay? And this was one that tripped up a lot of people. It gets worse when you're dividing by something with a negative exponent. So our raw answer is 0.8611111 repeating times 10 to the negative 23rd. And of course we have to do that whole thing of counting, and this is a great example because there's not enough space to put in the number of zeros we really need. So you kind of have to start to develop the pattern thinking for yourself. And I'm going to go, okay, 1, 2, 3, 4. Okay, I'm going to have to come back one further. So 8.6 times 10 to the negative 24th. The easy part to remember is if you're moving the decimal space 1, that exponent is going to be 1 different from what you currently have. The hard part for me has always been, is it going to be larger or smaller? Positive exponent, negative exponent. And that's why I draw bumps. Okay, so that's our answer for that one. So we've got the last one. 5.3 times 10 to the 8th divided by 3.9. Oh, did I not give you one that was truly evil? Darn it. 3.9 times 10 to the 15th. I'm always looking for opportunities. Okay, so our raw answer, this one was nice. Actually, this was the anti-evil. It was really kind. You didn't even have to move the decimal. 1.3589, etc. times 10 to the negative 7th. And I didn't show my work there. Times 10 to the 8 minus 15. So final answer, again, and I took it, I'm not worried about your rounding yet. 1.4 times 10 to the 7th, negative 7th. Okay, having seen solutions for these, if you had issues, can you identify your own issues? Okay, that's all we're going for. You watched the conversions video last night? Okay. We are going to start in earnest doing conversions on Monday. So what I'm going to do right now is talk a little bit about base units, because I kind of want you to, and I know it's homecoming weekend. Like, seriously, Moser, we're not doing a whole lot of stuff. A lot of us are going places. We have plans. If we're not going to the dance, we're going someplace else, to the anti-dance, like to a museum or to a concert or something. You wouldn't assign anything. I wouldn't. What I want you to do at some point in your busy, 72 hours from now until Monday, is I want you to take a look in your book at the table on page. At some point, I want you to take a look in your book at page 35 in Holt Modern Chemistry. Mod Chem. I want you to look at those prefixes, and I want you to copy down the following information for the following prefixes. Let me not screw this up. Use that note card while you're doing homework. You're going to fly without it at some point. Okay, so I want you to copy down the following information. The prefix, the abbreviation, the exponential factor. So just those 3 pieces of information. And I want you to do that for, and I'll give you the abbreviation for the ones I want you to do it for, mega, kilo, centi, milli, micro, nano, and pico. So those ones, 1, 2, 3, 4, 5, 6, 7, those 7 are the ones that you're going to end up being responsible for. So for right now, I just want you to copy those so you've seen that information for all 7 of those. And other than that, I want you to have an enjoyable, beautiful fall weekend. And if you're going to the dance or not, go outside and put some sun on your face and kick some starting to fall down on the ground leaves around.